All right, circular motion, a go-go. So your challenge is to figure out the solution to this problem. So we got a student, 60 kilograms, is riding on a roller coaster that goes upside down at 20 meters per second through a loop that has a radius of 15 meters. How large is the normal force acting on the student at the apex of this loop? So we want to know how great is the normal force acting right here on this student if it's going at 20 meters per second at that point with that radius and they happen to have that mass. All right, so I want you to do your best, see what you can do, pause the video, I'll come back with the answer and we'll see what we see. All right, so there's your answer of 1,012 newtons as your normal force. So if you got that, awesome, you're on track. If not, let's see what we can do. So one, I know that you can do these two things, and that is draw a beautiful force diagram. So let's do that right now. There's my force diagram, and I also listed out my givens. So let's just kind of walk through that, see how we got there. So first of all, we're moving. So let's say I'm going like this. So I guess I'll have a velocity here of 20 meters per second. And there's my radius, and I know the mass of the person. Now when you're at the top, gravity's always pulling you down, but the seat is also pushing you down too. So you also have a normal force from that seat as well. And then since the circle's below you, you're going to have a centripetal acceleration that's pointing down towards the center of that circle. Again, really crucial to identify where the center of that circle is, so you know if your centripetal acceleration is going to be positive or negative. Once you have this, you can do a net force equation in the y-plane, which is really your centripetal acceleration plane, and see where it takes you. So that's my recommendation. Do that net force equation. See if you can now get that normal force. All right, so give that a try, and I'll let you know if you're on the right track. All right, there's your answer. Net force equation, sigma c equals mac. The sum of the forces in the center of the circle. You've got a negative force of gravity because it's pointing down. You have a negative normal force. It's also pointing down. Equals mass times your acceleration. Now, here's the thing. Your acceleration is a negative value because it is pointing down. So, I mean, you could calculate this off to the side, get a value for your acceleration, and then put it in here, but it has to have a negative value. So just make sure that shows up in the situation. So you know mass, you know the gravitational field strength, don't know normal, know mass, know the speed, know the radius. It's all there. Solve for the normal force, and you get 1,012 newtons. All right, so hopefully that was helpful, and I'll come back with another one.